So finally, we'll talk about some built-in limitations to the Bitcoin protocol and why it's challenging to actually improve them. There are a lot of hard-coded constants that are implemented into the Bitcoin protocol, which were chosen when Bitcoin was proposed in 2009, before we really had any idea that it might grow into this globally important currency. So the most important limits are probably the limits on the average time per block, the size of blocks, the number of signature operations in a block, and the divisibility of the currency. The limitations on the total number of Bitcoins in existence, as well as the structure of the mining rewards, are very likely to never be changed because the economic implications of changing them are too great. Miners have invested a lot of real-world resources into becoming miners, assuming that Bitcoin rewards would take a certain shape and that the limited supply of Bitcoins would remain the way it's been planned. So if you change that, that would have large financial implications for people. So for that reason, the community has basically agreed that those values, whether or not they were wisely chosen, we're basically stuck with. Some other changes you'd like to make seem like they would make everybody better off. Things about Bitcoin that just weren't quite properly designed at the beginning, but are also hard to change. The main aspect of Bitcoin that people are worried about and would probably like to change if they had time to design it over again are limits that affect the throughput of the system. How many transactions can the Bitcoin network process per second? So this limitation comes from the hard-coded limit on the size of blocks. Each block is limited to 1,000,000 bytes. And each transaction has to be at least 250 bytes. So if you divide through and the fact that blocks are found every 10 minutes, you're left with about 7 transactions per second, which is all that the Bitcoin network can handle. And it seems like tweaking those numbers would be very easy. It's just one constant in a file somewhere that you'd have to change. It would actually be very hard to change this in practice for reasons that will become clear in a few seconds. So how does 7 transactions per second compare? Well, if you went down to the offices of Visa and told them I'm proposing a new payment system that can handle 7 transactions per second, they would probably tell you, that's terrible, and then they would laugh and throw you out the door. They've been working for a long time to build a payment network that goes way bigger than this. So it's said that Visa handles on average about 2,000 transactions per second around the world. And on the busiest times, so think the Saturday before Christmas when everybody's out shopping and swiping a credit card, the Visa network can handle about 10,000 transactions per second. And other payment card networks are similarly big. You can also look at PayPal, which is not as big or as old as Visa, but even PayPal can handle 100 transactions per second at peak times, so an order of magnitude more than Bitcoin. Another limitation that people are worried about in the long term is that the cryptography in Bitcoin is fixed. There's only a couple of hash algorithms, and there's only one signature algorithm, which is elliptic curve DSA, over a specific elliptic curve called SEC-P256. And there's some concern that over the lifetime of Bitcoin, which people would like to be for a long time, this algorithm might be broken. Cryptographers might come up with a clever new attack that we haven't foreseen, which makes this an insecure algorithm. And the same is true of the hash functions. Hash functions in the last decade have actually seen steady progress in cryptanalysis, with SHA-1, which is included in Bitcoin, already having some known cryptographic weaknesses. So to change this, we would have to extend the Bitcoin scripting language to support new cryptographic algorithms. So what would it look like to make a change like this, where we just said, we had a problem in Bitcoin, we're going to release a new version of the software, and everybody is going to have to switch? This is what we would call a hard forking change. So in practice, it's impossible to assume that every node would upgrade. Some nodes in the network would fail to get the new software or fail to get it in time. And what would be the implications of that? Well, let's take a look at a network here where most of the nodes have upgraded, but there are a few that haven't. And now let's say one of the new nodes says, hey, I found this nifty, great new block. Maybe it has some new signature algorithm in one of the transactions using the new features that we've added to Bitcoin. So block 4 has found this and says, OK, I'm going to update and say that's now the newest block. So I'm at block index 24. The rest of the network is at 23. But I'm going to propagate that to all of my peers using the normal block flooding algorithm. So node 4 is going to send block 24 out to its neighbors, nodes 3 and 2. Node 3 is going to get it and say, great, I got that one. I'll update my version of the blockchain to have that as the newest block. Whereas node 2 is going to say, that's crazy. You have some operation code that's disabled or reserved. I have to reject this block. I don't understand it. I can't accept it. And similarly, when it gets over to node 6 is also going to say, nope, I can't accept that block either. And now you're going to end up in a state where the new nodes have one picture of the blockchain, and the old nodes have all refused to accept this latest block. So the new nodes will go off and work on a version of the blockchain, including this new block with the new fancy feature. And the old nodes will all be stuck on an old version of the blockchain. And unfortunately, they're never going to catch up, because until they upgrade their software, they'll keep rejecting all of the blocks that are proposed by the nodes in the network that have upgraded to the new version of the protocol. So the reason it's called a hard fork is that the blockchain will split. Every node in the network will be on one side of it based on which version of the protocol it's running, and they'll never join together again. And this is considered unacceptable by the community, that old nodes would effectively be cut out of the Bitcoin network if they don't upgrade their software. So by contrast, there's an approach called soft forking, which tries to avoid creating a permanent fork like this. The observation is that we can add new features to the Bitcoin protocol if they only restrict the set of valid transactions or the set of valid blocks. Because we want to avoid this hard fork situation, we can try to add new features in a way that will cause only a soft fork. So the key to making this happen is that the new features can only make validation rules stricter. They can only limit the set of blocks or the set of transactions that are considered valid. So the new nodes in the network will be enforcing some new, tighter set of rules. So we're relying on enough nodes switching to the new version of the protocol that they'll be able to enforce the new rules, knowing that the old nodes won't be able to enforce the new rules because they haven't heard of them yet. There is a risk here, which is that old nodes might be mining an invalid block because they include some transaction which used to be valid, but according to the new, more strict rules, is not valid anymore. So that could be bad. Those nodes could waste a lot of time mining a block that the new nodes will reject. But when they try to announce that new block, the new nodes will reject it. The old nodes will at least figure out that for some reason, even though I don't understand the reason, the rest of the network has rejected my new block. Therefore, I should move on to the version of the blockchain that all of my peers have, and it won't be a hard fork. They'll have a temporary fork by virtue of the new block they tried to mine that was rejected by the network, but they'll recover and get back onto the main chain. So the classic example of a change that was made via a soft fork was pay-to-script hash, which we introduced earlier in the section discussing the scripting language. So the view of pay-to-script hash from old nodes, and again, pay-to-script hash was not present in the first version of the Bitcoin protocol, they see this script as really simple. All it's doing is hashing this one data value and checking to see if it's equal to the value specified in the output script. The old nodes never do that second step of verification in pay-to-script hash, where they then check to see that that value before being hashed runs as a valid script. So what could we possibly add with a soft fork? Pay-to-script hash was successful. It's also possible that new cryptographic schemes could be added by a soft fork, or that we could add some extra metadata in blocks that had some meaning. And the place you'd add this is in the Coinbase parameter. So today, any value is accepted in the Coinbase parameter, but we could in the future say that the Coinbase has to have some specific example. One idea that's been proposed is that in each new block, Coinbase contains a Merkle root of the entire set of unspent transactions. It would only result in a soft fork because old nodes might mine a block that didn't have the required new Coinbase parameter that got rejected by the network, but they would catch up and join the main chain that the network is mining. Other changes might require a hard fork. That would be if we wanted to add new opcodes to Bitcoin, change the limits on block or transaction size, or do a lot of bug fixes. So for example, the bug I showed earlier, where the multisig instruction pops an extra value off the stack, that would actually require a hard fork. And that's the reason why, even though it's an annoying bug that people wish wasn't there anymore, it's much easier to just leave the bug in the protocol and have people work around it, rather than have a hard fork change to Bitcoin. So all of these hard forking changes, even though they would be nice, are very unlikely to happen, at least within the current climate of Bitcoin. But a lot of these ideas have been tested out and proved to be successful in alternative currencies, which start over from scratch, and we'll be talking about those in a lot more detail in our lecture on altcoins. So I spent a lot of time talking about details today. I know this has been a long lecture with a lot of technical detail, very hard to absorb it all at once, so like I said, I would certainly recommend you can go online and see some of this stuff in practice, see what blocks and transactions look like. It took me a couple of times looking at them before I really had a good sense of what was going on, but I think the practical examples do really help. In the next lecture, given all these mechanics we've introduced, we're going to look at the human side of things. Because after all, human beings aren't Bitcoin nodes, and you're never going to run a Bitcoin node in your head. So how do you as a human actually interact with this network to get it to be usable as a currency? How do you find a node to tell about your transaction? How do you get Bitcoins in exchange for cash? How do you store your Bitcoins? So all of these questions are crucial for making a currency that will actually work for people, as opposed to just software.